Hello everyone, and welcome to our session on working with origin destination data and so-called activity data, by which we mean travel activity, so movement patterns, to model decarbonisation, so to try and get insight into how the future could be under a dramatically different transport system. So a lot of this conference has been about the shifts needed to get to real zero carbon. And it's clear a recurring theme is that we need more than just technology, we need behaviour change. So it's not enough just to rely on the current travel patterns and hope that technology is going to save us, so to speak. We actually need to change our behaviour. And this is largely unknown. This is going to be the biggest shift in travel patterns since the invention of personalised automobiles, probably. And it also needs to happen quicker than the uptake of the private automobile. So we're talking about a revolution in transport systems. So this is big stuff, and we need all the help that we can get to understand this and ensure that this happens. So that's what we're going to be presenting on. I'm just going to introduce ourselves before going into the substance of the talk. So I'm just going to stop sharing because ultimately this is about people as well. So just to provide a bit of context on who I am, who we are presenting this. So my name is Lovelace. I'm an associate professor.
I can't hear you. Maybe that's just me.
I'm an associate. Can everyone else hear me? I guess so. I'm just hearing someone speaking on the mic. General thumbs up.
I can hear you fine, Robin.
Okay, that's good to hear. So yeah, maybe check your audio settings if you can't hear me. So yeah, I'm an associate professor of transport data science at the University of Leeds. I'm based in the Institute for Transport Studies and the Leeds Institute for Data Analytics. So I'm very much into new methods, data science, but I'm also have a particular interest in sustainable transport, and obviously that contributes towards decarbonisation. And I've been working on various projects. I'm the lead developer of the Propensity Cycle tool, which is a multi-university project that isn't just academic. This is being used by the majority of local authorities across England and Wales to plan strategic cycle networks, and it's being used to influence the investment of hundreds of millions of pounds across the country. So this isn't just theoretical. We are talking about building tools that will go into use and lead to more effective and more cost-effective policies. So the Propensity Cycle tool, that's a project that was started 5 years ago, that is now in production and it's deployed nationwide. What we're going to be talking about here is much more cutting edge. So technology's moved on, and I'm really excited to be able to present some new stuff and new software that can go to the next Zoom level in terms of being able to represent scenarios of change. We've got limited time, so I should probably stop talking about the project and move on to talking about the actual session, which is about working with data, origin destination data, to help support evidence-based decarbonisation policies. But before I do that, I just wanted to introduce the team that I'm working with on this, and maybe if you want to say a very brief hello. So we've got Lucas, who's based in Sao Paulo in Brazil. I'm working with Lucas on a World Bank funded project looking at road space reallocation in Sao Paulo, which is the biggest city in the southern hemisphere that has huge problems with congestion, and we're looking to address those. So do you just want to say hi, Lucas?
Hello everyone, nice to meet you all.
Great, so that's Lucas, and then you'll also be hearing from Nathaniel, who's doing a PhD in Exeter, and is going to be showing you some visualization stuff. So do you want to just say hi, Nathaniel?
Hi everyone.
Great, so yeah, that's us. Now on to the actual substance of the talk. So I'm going to share my screen, and if anyone's got any questions, feel free to put them in the chat. But obviously time is of the essence, and we're going to make time for questions. Okay, so if you've got any questions brewing, just think about them, put them in the chat, and you'll have an opportunity to ask those over audio. So just to recap, I guess people have signed up to this session because they're interested. Obviously, we're all interested in how can we decarbonize the transport system as part of a wider set of policies that are needed to get to a zero carbon transport system, a zero carbon economy, which is needed, obviously, based on the science that shows we need to get to zero carbon quite quickly, and data can help with that. Obviously, you need the politics and the policies in place, but the policies, once you've decided that we need to get to zero carbon, there are many options, and it's hard to decide between this very wide range of policy measures that could help, and in some cases could actually make the system, the situation worse, the law of unintended consequences. So the more data that we have and the more evidence-based these policies can be, the more likely that they are to be effective, and the more likely they are to lead to the rapid transition that is needed. So that's the context. One interesting quote that I picked out, which is from the 2018 report, that just made the recommendation that future transport modelling tools are open source. And I don't need to speak at length about this, but essentially, if transport models are open, they can be reproducible and they can be transparent, and other people can build on them. So that's one of the motivations behind what we're doing. I'm not going to read this out. But yeah, so this workshop's just about us presenting these new tools that we've got, and they're open tools, so people can take them and play with them. You can, if you're working with someone who is into the technology, even if you're not into the software yourself, you can kind of tell people about this, and it's open to use, but it's very much work in progress. I am going to open this one link though, which is just showing the power of origin destination data. So what do we mean by origin destination data? It's simply data that represents movement from one place to another. And in the UK, or England and Wales in this case, we're lucky because we've got a big amount of open access origin destination data, as known as OD data. And this represents a huge amount of travel. So you can use this as the basis of modelling. And that's great, but it's not particularly necessarily policy relevant when you just do it at this national level. So there's a mismatch between the scales at which a lot of decarbonisation models are running, which tend to be at the national and regional scales, and then the geographic scale at which transport policies in particular are implemented, which is at the local level. So we're talking about neighbourhoods and even individual road segments where you make changes to the transport system. And this modelling approach is aiming to kind of bridge the gap between those two levels. So you can have a national model, but unless you can get the results at the local level, the results may be of limited policy relevance. So I'm going to do a bit of a demonstration of using this data. I'm using the statistical programming language R, which is widely used in academia and increasingly in industry, but you could use different languages. So we're kind of software agnostic, but R is great for reproducible research and visualization. We're going to do a live demo with this AB Street software, which allows you to go from visualizing origin destination in static maps, like the map that I showed of England and Wales, into a real-time simulation, which is a very interesting and I think powerful technique with big potential to inform policy. We're going to show a new data set. We're going to visualize this new type of data, and then we're going to open it up to more of a conversation. So we're going to ask the question, how can we model destination switching and working from home, which is something that I think has grown massively with the pandemic. And we're also going to ask the question quite broadly, how can we use these modelling approaches to support efforts to decarbonise transport systems in terms of the research and the policy. So we are thinking about putting this work into policy, and to some extent we already have. So yeah, just a little bit more context before I go into the more kind of technical hackathon side. It's important to get an insight into how we can use this for policies. So I'm sharing a screen here that is of a prototype tool that was funded by the UK Research and Innovations Strategic Priorities Fund. So this was a 4-month project to demonstrate the potential for new technologies to inform the planning process. So what kind of developments should you give planning permission to from an active travel perspective? So the project's called ActDev. We're really happy with the results, especially as we did this in a rush. So the kind of strapline of this conference is real zero in a hurry. And if we want the policies to happen in a hurry, the modelling also has to happen in a hurry. So these models can be rolled out quite quickly. And what you can see here is real data on specific development sites, and you get a very quick indication of how good or bad the transport performance of these new sites is likely to be. So that's useful, but it doesn't really give you much to go on, other than say, well, maybe we shouldn't invest in this one, which is Hampton, which has a lot of red. Maybe we should invest more in ones that have high walking and cycling potential, like this one in Exeter. So that's something that already exists, but this isn't the tool itself. This is just high-level data. So the tool itself opens up when we click on one of these, and I'm going to use the Leeds Climate Innovation District because it's actually unusual in that it's an example of a real development site that's actually quite good from a climate perspective. It's the Leeds Climate Innovation District, so it's designed to have low environmental impacts and high levels of accessibility. So the idea is you're not locking people into car dependency. And these kind of developments could be developed in cities around the country and around the world. And this is the kind of developments that we need to get to real zero in a hurry. And what it shows is if you're thinking about a development site, it gives you basically a rating, so a sustainable transport rating. And overall, this one's yellow. So assuming the residents of this new place have the same travel patterns of people living in the surrounding area, about 40% of them would travel by active modes. But the real usefulness of this in terms of policy comes in when you look at the origin destination data. So in red and blue, this is OD data, but we've assigned the origin destination data to the road network. So this picks out areas where you need to improve the accessibility. So this is saying, for example, to encourage more walking and cycling in this area, they've got good accessibility up to this point. So this is how quiet the roads are. It's an estimate of busyness. But once you get to this place, they may have to walk or cycle on a busy road. So this could be a targeted investment, and that could lead to highly cost-effective ways of getting more people cycling. So that's good, and it gives planners plenty of information. There's other data layers that we can see here. What are common destinations in the area? So this shows that there are plenty of destinations within walking and cycling distance in this site, unlike other sites that are kind of out where you may be locking people into car dependency. So this is all useful, but it doesn't really allow you to see the complexity. And if you want to redesign junctions and actually look at the detail, you need something else. So that's where this technology of real-time simulation, agent-based simulation comes in. So the next step, and this is something that we did fairly new for the project, is we simulated the travel patterns in this area, and that is new. I've never done this before, but you can see basically you can observe how the people could respond. It's obviously it's not reality. Every model is a simplification of reality, but it gives you a way of picking out things that you can't see just with a map that isn't responding in real time. So that's what we've done. In terms of the technology, we're using AB Street, which is a open source traffic simulation model developed by Dustin Carlino, and it's very popular on GitHub. It's got 6,000 stars, so it's very, very popular among developers, and it's written in this new systems programming language called Rust. So if you're into the computer science, there's loads to look into, but we're not going to be talking about that. What I'm going to be talking about is this interface to AB Street that we've developed, and we've called this AB Street. So we've developed an R package that is published on CRAN, which is the main place where R packages are hosted. So we've developed open source software that converts the origin destination data into a format that can be analyzed and visualized in the AB Street simulation software. So yeah, that's the context. So going back to this, I'm going to do a very brief demonstration of what this looks like in R and RStudio. I did say it would be a practical hackathon, so I hope people have got their computers ready. I hope you've got RStudio installed. If you haven't, don't worry, you can just watch and listen and participate in the kind of discussion. And this may be a motivation to install some of this software, because it is powerful, but it takes a lot of time to work to learn as well. So I don't expect people to learn an entire programming language in one afternoon. So yeah, I'm just going to do a brief demo of this. The first thing that I should say is, how do you install this? So assuming people have got RStudio open, the first thing that you can do is install the AB Street package, and we're going to use the development version of this package. So the way that you do this, well, first, and this is assuming you're starting right from the beginning, to install new packages, you can use the function install.packages, and I'm going to type in remote, and I'm going to select this option, which is remote. So I'm going to install a new package, and what that package does is it allows me to install other packages that are in development. So this is definitely a package that's in development, and then I'm going to install from GitHub, which is the #1 place where open source software is hosted worldwide, and our software is on GitHub. And then if you want to install the AB-Strua package, what you can do is type in install GitHub and then in quotes A-B-Street and AB-Strua. So obviously the name comes from AB Street, but it's the R version, so AB-Strua. And I'll just give people a moment to type that in and check that you've got that, everything's working. And if anyone's got any questions, by the way, do please share on the chat. Okay, so yeah, that's the first technical thing that we can all do together. So 1, 2, 3, I'm going to run that, and you should see something like what I'm seeing. It should install. It might take a bit longer on your computer, depending on what packages you've already installed. So once you've done that, you've got this software installed on your computer, and you can start using it. Another thing, and basically at this point, you can run through the example that I'm going to show, which is, so this is the package. This is the package website, and I'm going to share a link to this tutorial, so you can follow along. And to be honest, given that we've only got an hour, this can just be a pointer and a kind of introduction to this. So at the very least, you can see what's possible without, and it might take a bit more time to get your head around it and see what's going on. So all of the code here is building on this. It starts with this very simple design of what we mean by activity data. So I was told early on, when I was just getting into doing programming, a guy gave me some very good advice, which was, I asked him, how do I get good at programming? And he said, the best advice I can give you is don't start with code, start with a pen and paper. So I just kind of drew down this sketch to illustrate what I'm talking about. And you can see this is a kind of conceptual structure that can represent a wide range of activity patterns. You have the origin of the trip, the destination, the departure time, and then you have a person ID. So this simple example just represents a single person who gets up in the morning, and at 8:30 they depart for work, and then at some time they arrive at work. We don't need to know that time. That depends on how far they've got to go. And then at 11:30, maybe they get a bit restless, and then they want to go for a walk. So they walk to the park, then they want to get a coffee, and then they go back to work, and then they go back home. And this goes much beyond the origin destination data that I showed earlier, where typical commute data only contains one type of trip, which is the trip to work. So this is a more sophisticated type of data that actually captures a higher proportion of trips. Commuting data only accounts for about less than 20% anyway of trips in most countries, certainly by distance. I think it's 19% by distance. Anyway, I'm going to run this live example. So once we've installed the package, you can load it with this command library, and I'm pressing Control and Enter here, so it loads. This stuff is just code that I wrote to support this. So it's actually based on an example in Leeds. So this is actually real data where you have home location, and you can see that, and you have all of these destinations, but you can represent that as a simple data frame. So this is really simple data. I mean, it's got 4 columns, it's got 4 rows and only 3 columns. So it's got a name and a destination. And although it's a small example, the structure can be used to model big transport patterns. So we're going to convert that into a spatial object, and very quickly, just to show that this is these are real locations. We can view that on an interactive map with places SF, and you can see these are locations in Leeds. So yeah, it's a simple representation of that sketch that I presented at the beginning, and we're now going to create a digital representation of that sketch of data. So this is again data, and then we can convert this into a desire line format. So this just shows the travel between those locations, and then we can set the departure times. So I won't talk about this in detail, but basically we're converting the departure times into a format that AB Street uses, which is seconds after midnight. So yeah, and then finally, we convert this data into a JSON representation. We can save it, and then I can open this. So file.edit scenario 1.json. So bingo, we've converted the data into a new form. What we can do now is to import this into AB Street. So that's new. That's something that we can do. And previously, all of the scenario generation happened in AB Street. So this provides a way for people to develop models in one language, R, which is very good for model development and statistics. So we can build uncertainty, we can control many aspects of the model. And then when we're ready to visualize this and look at the consequences, maybe in terms of congestion, maybe in terms of the consequences for the infrastructure, because you can edit the infrastructure in AB Street, you can look at it. So that's basically what we've done. And this is brand new. This has only been possible over the last few months since we've developed this AB Street software. So that's the demonstration with R. In terms of the live demo with AB Street, I can say, here's one, Blue Peter style, here's one we prepared earlier. So again, this is something that Lucas and I were working on yesterday. So it's very, very, yeah, it's very, very new. It's brand new. So basically, yeah, Lucas is going to say something about this data, but I'm just going to say for now, this is a bigger data set that represents an activity pattern in Sao Paulo, which is, as I mentioned, we're working on a project in Sao Paulo. And once you import it into AB Street, this is what it looks like. So you can actually see the agents moving around. At the moment, there isn't anybody doing anything in Sao Paulo, so I'm going to speed it up. I'm also going to cross my fingers because this is the first time that I've actually run this beyond this point. So you can see there you had another agent. So you can see people should be appearing on the map. So I could see one agent here, and basically it builds up this pattern. And what we want to look at is where do you have intersections between the car trips and the walking trips and the cycling trips. So where's the potential for conflict? And also, where are the places where you need more space for cycling, more space for walking, to enable people who are currently using the car to switch safely to walking and cycling. So this representation of the data is, I think, very powerful. And I could just see that I think there's an agent, that there's a person somewhere along here walking around somewhere. So you can actually see them and you can get an insight. You learn a lot about transport systems when you look at them at this level of detail. For example, if someone's got to walk along this huge road, that's probably not good. It's probably a sign that there's a need for walking infrastructure in this area. And the amazing thing with AB Street is you can actually edit the roads. So it gives you massive control, amounts of control over the system, you can actually edit the traffic signal timings. And with decarbonisation, it's such a big problem that I think people get overly focused on the big picture without thinking about the detail. But as with any kinds of policy, the devil is in the detail. So you need to take account of the details, such as traffic signal timing. So I think, if you had across all of Leeds a change in traffic signal timings to prefer to bias towards walking, that could potentially have a bigger impact than some of the other policies like building new cycle infrastructure. So this allows you to simulate those kind of things. So I'm just going to kind of keep moving forward, see if I can. I just saw someone else. So yeah, this thing does scale as well. Like, we've only got 20 agents, and at the moment there aren't many of them who are in the map at the same time. But this can scale to working with many hundreds, thousands of agents. So I think I'm probably gonna, that's enough about AB Street. I mean, it is an amazing piece of software. I could start editing roads. So I could simulate what would happen if we converted this lane into a walkway. So you can actually transform the city and create car-free zones, do all kinds of simulations. And that goes way beyond what we've done previously, which just is creating scenarios of behavior change. This software allows you to simultaneously do scenarios of infrastructure change and behavior change, and also it's participatory. So because it runs in a web browser, you can get people to redesign their cities. You can run experiments of quite big changes before you make them in reality. And I think that could also help with public acceptance of those changes. So that's a live demo of AB Street based on this new example. And we've got 5 agents moving around at this stage. And I'm just going to try and see one of them because that would be fun. So let's see if I can pick any of those out. I think there is a way of identifying individual commuters on there. But I'm not, trust me that you can just see people walking around and get an insight into how that looks. And I can see loads of questions on the chat. Keep them coming. We're going to make sure that we address those later on. But right now, I'm going to go back to this because it's Nathaniel's going to be, Lucas is going to talk briefly about why are we looking at Sao Paulo? What is this data? How readily available is it? And the answer is it is very available in many cities. So Lucas, over to you if you want to say something very briefly about the input data that you need if you're interested in creating simulations like the one I just showed.
Yeah, hello everyone. I'll share my screen very quickly to show you the original data where these example data that Robin showed came from. It's a very, very big survey data from São Paulo. They try to represent all the trips in São Paulo metro region. So we have here almost 200,000 observations and 128 different variables. So it's a very complete data set. We have a lot of socioeconomic information like the income per person, the reason why they move, and the industry people work. And since it's a survey, we have also some survey weights to represent the universe of trips in São Paulo metro region. So what you just saw in Robin's example was just a random sample of 20 agents of this big survey data. So it's open data. Actually, you can download it just easily, and in the AB Street package, you can really, with one line of code, you can download this little example data frame with 20 people, that I mentioned. And there's also a smaller one with 2 different people. But we're planning to make this whole data set available for everyone. So if everyone is interested, you can get in touch with me. I'll be happy to help everyone. And indeed with the Portuguese itself, because everything's in Portuguese. So if everyone is interested, please get in touch. And I think that's it. It's a very, very big data set. I would not be able to show everything today, but we have the modes of transportation, all the transfers people make in each trip. And yeah, I think that's it.
Fantastic. So yeah, thank you for sharing that. And I guess, yeah, we want this to not just about what we're doing, we want this to be useful. So if anyone's developing sophisticated models of decarbonisation that don't just work on aggregate data and you want individual level data, this could be a really good resource. It's the most detailed open access travel survey data set that I've seen, comparable to the UK's National Travel Survey, but it is completely open access, and big credit to the government institutions in Brazil for making that open, because it really enables the kind of transport modelling stuff that is needed, I think, for more effective policies. So yeah, that's really good. I'm going to hand over to Nathaniel in a second, but first up, I just want to say something in terms of getting in touch with us. So there's various lines of communication. You can find our emails and send us an email, but I would encourage everyone, especially if you're into the tech, to contribute on GitHub. So you just need to sign up for an account and you can communicate here. So you feel free to open an issue asking a question. And that's a good way that if you do it this way, not only you benefit, but everyone can benefit from that conversation. There's also a discussions page here, and I can just create this discussion page. So if someone wants to ask a question, but it's not really an issue with the package, you can do that here. So I'm just going to share the link to that. And then finally, in terms of visualizing data, well, I get the short end of the stick really, because I have to visualize static data. So, you know, this isn't a particularly intuitive way of representing this data. You have home, work, but this looks like something that came out of the 1960s computer graphics. So I'm going to hand over to Nathaniel about taking this visualization into the 21st century. So if you've got about 5 minutes to do that, that will leave 15 minutes for people to have a play with this and also to ask any questions. So I'm going to stop sharing now and hand over to Nathaniel, who can talk about how R can be used to visualize this data, even without AV Street.
Great stuff. Cheers, Robin. Can you guys see my screen?
Yep.
Lovely stuff. So here we have the same representation what Robin first introduced, of going from home to work to cafe and then back home. In this way, we're using Mapbox to just present simple straight OD lines going from one place to another. This can give us a really quick and easy visualization of that activity model in really not that many lines of code. So this is the code for that one. What I will share with you guys on the chat. And also we can then take this sort of, I guess, a little bit further and look at routes as well. So again, this is Leeds here. We have 2 small little agents. I call one Robin and one Robin's neighbor. The timing on this one is not correct, but what we've done here is use the route to basically simulate each of their journeys. So this is now following a route used in the SD Planner R package to understand the various routes that they're going to take to go to their work. So we can see this one's going down now Clay Pit Lane and up to Potternewerton. Again, these are two very, very quickly made visualizations made with R. They are a great introduction to sort of visualizing the data, understanding the data before being able to add it into something like AB Street. So yeah, this journey will now go on for their various days. So yeah, I will share the links of the code for both of these examples. So if anyone wants to mess around and try it with either the data that we've provided in AB Street or any data that you have as well, let me know if you have any issues, and I'm happy to help.
Okay, fantastic. Thanks for that, Nathaniel. So yeah, you've got options. I mean, that's one of the things about open source software is it's designed to give you more options rather than just make you go down a certain pathway. And also these tools are modular, so you can chop and change which tool you use for which job. There's rarely a one tool to solve them all. So use the tool that's appropriate for the particular task. And you can also use Python to generate these kind of data sets. So there's a Python package called OD2Demand, which can generate these kind of scenarios. So we want to give people the flexibility to do what they want, and we don't want to constrain people, because with decarbonisation, we need to think outside the box. And I think transport modelling for too long has been just quite conservative and thinking inside the box, but actually these kind of tools enable you to implement quite a wide range of different outcomes. So what